In this demo, we're going to test the reliability of an online banking service, the fictional Bank of Anthos. So when I first log into Gremlin, the first thing we'll see is the services dashboard. This page lists any services that I or my teammates have already added to Gremlin. Now, a service is just a set of specific functionality provided by one or more systems within an environment. Think of something like a checkout service or an authentication service. In Gremlin, services are the units used for reliability measurement and improvement. And this dashboard provides a central view of reliability scores in services that you can see across your entire organization. Simply put, services with higher scores indicate that they've been more fully and more recently tested, while services with lower scores have had less testing done. Now, one of the most important functions of any bank is the ability to record transactions to a ledger, which is why our application has a dedicated ledger writing service. This service is critical to our bank's operations, but we don't yet have a view of its reliability. So we'll use Gremlin to run a few reliability tests and ensure that it can stand up to different failure conditions. So I'll start by adding a new service by clicking this Add Service button. And the way you define a service in Gremlin is by identifying a single process running on one or more hosts, containers, or Kubernetes resources. First, I'll enter a detailed name for the service. And for the type of service, this application is running on Kubernetes, so I'll select Kubernetes. Then I'll click Next. Now, I need to select the Kubernetes resource that I want to test. I could expand the drop-down menus here and select the resource that I want from here, but I can also enter its name into the search box up here and have it pop up and click it on this way. Now that it's selected, I'll scroll down and click Next. Now we also need to select the process running in our container. Gremlin uses process data to discover network dependencies and customize a reliability test for this service. Gremlin detects processes automatically, and if Gremlin detects only a single process, it automatically selects it from the dropdown. I'll confirm that my ledger writer process is selected, then click Next. Now, we need to connect our golden signals. Golden signals are the key metrics that we use to monitor the health of our service, such as latency, traffic, error rate, or resource saturation. To connect our golden signals, we'll first select the type of integration to use. Gremlin natively integrates with Datadog, PagerDuty, New Relic, and several others. Or you can also enter a custom URL for integrating with another tool via REST API. Now, I use Datadog, so I'll select Datadog for the integration, then click Add. I already set up my Datadog credentials with an API key, so all I need to do here is copy and paste the URL of my monitor. Gremlin will automatically retrieve the monitor name from Datadog and checks to make sure that it's successful and responsive when I click the Test Golden Signal button. I'll look to confirm that this returned an HTTP 200 status code and that the contents of the monitor reported as OK. And since this looks good, I'll click Save to add it to my service. Now, whenever I run a reliability test on this service, Gremlin will run this golden signal, check my monitor, and make sure that all of these criteria are met. If the monitor reports it's unhealthy or takes too long to respond, Gremlin will immediately stop the test, return our service to normal, and mark the test as a failure. I'll click Next to move on to the next page. Now, we can decide whether or not we want to automate our reliability test. We expect our systems to change constantly, so we want a path to automate testing of these services, and we can do that by auto-scheduling them directly within the Gremlin UI. We can simply check this box to enable auto-scheduling. Then, we can choose whether to schedule all reliability tests, only reliability tests that have passed at least once, or any reliability tests that have been run at least once, whether they passed or failed. We can also set a weekly testing window by choosing a day of the week, like Wednesday, and specifying a window of time for the test to run during. And once we create our services, tests will automatically start and then end during this window. I'm happy with this configuration, so I'll click Next to continue. Now, we just review the service's details to make sure everything looks correct. This does, so I'll scroll down and click Create Service to create my service. Now right away, we see our new service's reliability score, but because we haven't run any tests yet, it's at 0. We can also see the different reliability tests that we can run, organized by category. Let's start with the easy test, like the CPU test. Now, this CPU scalability test validates that our service can still perform with limited CPU capacity. Ideally, our service will autoscale once CPU reaches a certain point, and we can use this test to verify that this works as expected. To run the test, just click Run. Gremlin will ask us to confirm that I actually want to impact the service, and I do, so I'll click Run again. And while the test is running, we can monitor its progress on the test page. We can see the details of the test, which golden signals Gremlin is monitoring, and also see any output from Gremlin while it runs the test. We can also stop this test at any time by clicking the Halt This Test or Halt All Tests button in the top right corner. So for now, I'll let this test run in the background, and I'm going to switch to another service where we've already finished a few tests. So after we've run a few tests in the service, you see our score starts to increase. We can also see which tests were successful and which ones failed. So for this particular service, the CPU test was successful, but our memory test failed. And if we click on it, we can see not only when it was last run, but also why it failed and which one of our golden signals triggered the failure. This is great for determining what we need to do to make the service more resilient, or if the problem is with the signal itself, how we should tweak our monitoring to better reflect the health of the service. Now, the score breakdown is pretty simple. Each test contributes a percentage based on the total number of tests in each category. We get 100% for a successful test, 50% for a failed test, and 75% if a test passed but hasn't been run in the past week. Gremlin gives points for a failed test because, even though it failed, it shows that we've taken steps towards improving the service's reliability. These points are then averaged across each category and then added together to give us the final score. This leaves us with an objective, up-to-date, and standardized way of measuring the reliability of our services. So now that you've seen how Gremlin Reliability Management works, why not try it for yourself? Start standardizing and automating your reliability one service at a time by visiting gremlin.com.